Okay, I think we're good to go. I'm recording this session. If you don't hear me, please let me know. And yeah, if you can't see my screen, then yeah, also let me know. I'm not sharing it at the moment. I'll share it in a minute. So this week we're going to start with learning unit 6, which is probability distributions. And we're going to split this up into 2 parts. So learning unit 6 we'll do one part this week and then we'll finish it up next week. Okay. And I'll tell you how we're going to split it up in a second. So just to give you an idea of what you can expect to do in this session, I am going to share my whiteboard and put things into context. All right, so let me share my screen, and if you don't see it, let me know. Okay, so just ignore the text here. Don't worry about that. Just focus on my writing, and I'm going to explain to you how we're going to split this learning unit 6 up. So learning unit 6 is probability distributions. Okay. It's probability distributions. And this can be split up into 2 types of distributions. There's distributions for discrete random variables. And by now, I'm sure you're familiar with random variables because you were tested on it in the assignment. So you get your discrete random variables, and you can also have probability distributions for continuous random variables. Now, there's a whole bunch of distributions for these, okay? But for this course, we're only going to cover a few. So for discrete random variables, there's just 2 distributions that you'll cover. One is the binomial, sorry. Okay, one is the binomial. Give me a second. Okay, let me go back. Okay, the binomial. That's the one type, and then the second type is the Poisson. And this is what we're going to cover today. We're going to cover this today. Next week, we're going to cover the continuous distribution. You're only going to work with one continuous distribution for this learning unit, and that is the normal distribution. It's probably the most widely used distribution out in the real world. So the normal distribution. But this is what we'll do next week. Okay, so this week, tonight, we're going to cover this. All right, so that's just to give you an overview of how we're going to split it up and what we're going to cover tonight and next week. All right, so let me clear this. Let me clear this board, and I'll explain the concepts by an example. All right. So here we have a problem, and I'll read through the text now. So I'm going to change my writing color. All right, cool. All right. So I'll read this text out to you, and I'll kind of give you an idea of what they're asking, right? What's the information and how we can use it to answer the questions. So we're given a scenario where there's a factory that produces smartphones. And from historical data or just from past experience, we know that the probability of a phone having a screen defect is 5%. So it's a 5% chance that these phones could have a screen defect. So it's quite a small probability. And so what happens is we have this quality control manager who is going to take a sample of just 10 phones. All right, so this quality control manager goes into the factory and just randomly selects 10 phones. All right. Now, question 1, so let's just focus on question 1. It asks, what is the probability that exactly 2 have defects? So exactly 2 of these phones have defects. All right, so what we have is this quality control manager selected 10 phones. So there's phone 1, 2, 1, 2, 3, 4, 6, 7, 8, 9, 10, all the way up to 10 phones. And we want to know what's the probability that out of those 10, just 2 of them have a defect. We don't care which 2. It could be this 2 that have a defect, right? Or it could be this 2. It doesn't matter. All we need to figure out is what's the chance that 2 of them out of those 10 have defects. So the first thing you want to pay attention to in this problem is that there's only 2 types of possibilities that can occur for these phones. In other words, a phone can have a defect or it won't have a defect. That's pretty much it. You can think of those as polar opposites of each other, or in other words, they're the complement of each other. They're the opposite. So hot, cold, you know, you can't swim or you can swim. All right. So it's the opposite of each other. So what we have is a case like that. The phone either has a defect or it doesn't. All right. So it's a binary outcome, yes or no. Okay. Has a defect, doesn't have a defect. So the moment you can identify that there's only 2 possibilities, so 2 possible outcomes, which are the opposite of each other, right? And they're the opposite of each other. Or in other words, complements of each other. And we have a fixed number of trials. In other words, there's only 10 phones that we're trying to work out probabilities for. So there's a fixed number of trials or experiments. So we have a fixed number of trials or experiments. And in our case, it's 10. 10 trials. Now, if these 2 criteria are met, then that means we need to use the binomial distribution. Now, just to draw your attention to something, in your exam, even in your second assignment, the question will very unlikely tell you that you need to use a binomial distribution. You need to figure out whether you do need to use it. So this is how you identify whether you're using a binomial distribution. Ask yourself these 2 questions. Are there 2 possible outcomes which are the opposite of each other? If it's a yes, you can put a tick there. Then ask yourself, is there a fixed number of trials or experiments? And in our case, there's 10 phones. So yes. And if these 2 are met, then you know you need to use a binomial. All right, that's how you identify if it's a binomial distribution. All right, so pay attention to that. So now that we know we're using a binomial distribution, let's go ahead and answer question 1. All right, so question 1 is, what is the probability that exactly 2 of those phones are defective? So we need to write this out mathematically. All right. So in order to write it out mathematically, we need to let some random variable represent what we're interested in solving. So we want to know what is the probability that exactly 2 of those phones are defective. So in other words, we need a random variable to represent the number of defective phones, smartphones. And so what the question is asking us is work out the probability that X equals 2. That's what we need to work out. Okay, that's how you express it mathematically. And once we can do that, then we can use the equation of a binomial distribution. Now I'm going to write the equation out. You don't need to memorize it, and it may look a bit complicated, but feel comforted that you don't have to memorize it because it is in your formula sheet. You just need to know how to use it. So the formula for the binomial distribution is P of X equals x. Wait, let me write a bit more on the left, so I got more space. Okay, I'll write it here. This is the formula. P of x, and I'll explain how to use it in a second, so don't be intimidated by it. Okay, it's n c x p to the x 1 minus p to the n minus x. That's the formula. Sometimes instead of x, you can have r. Okay, but it's the same thing. All it is, it's just it's a dummy variable. It's just telling you that you need to substitute the values that you're interested in place of that x. So if it was r, you'd replace r with the value that you're trying to figure out. So if we want this probability, all we got to do is use this equation and substitute the values that we need to in it. I'll talk you through all the values that you need to plug into this equation. So let's draw your attention to this letter here, n. With the first part here, n. N is just the number of trials. So in other words, in our problem, we have 10 phones or 10 experiments. So that's our n. All right, so n is 10. And c, now this c isn't really a variable. This is a function in your calculator. All right, so I'll talk you through how to use it. Okay, I did cover it in the video last week, so hopefully you watched it. But if you didn't, I'm just going to talk you through how to do it again. So your n is 10, and your x is what we're trying to figure out. So in our problem, our x is 2, so x is 2. So this part here that I'm going to write out, this ncx, this is a function in your calculator. And how we work that out is we're going to, okay, so get your calculator out. Okay, I'm going to talk you through how to do it. Okay, once you got your calculator open, if you look above the division button, okay, if you look above the division button, you will see that it has NCR. And that is the same thing that we're trying to get. Instead of R, we have X, but it's the same thing. It doesn't matter what letter they use in the calculator. We just need to know that instead of R, we are going to use X. So now if I want this value, what I'm going to do on my calculator, all right, is first my n. Now remember our n is 10. Okay, remember our n is 10 here. So I want to actually work out 10c, and what my x is, it's 2. So I want to work this out. So how I'm going to do that is I'm going to, in my calculator, I'm going to type 10 first. Okay, so type 10. Then you're going to press Shift and then press the division button, because now we're calling that function. So you're going to press Shift, and then you'll see in your calculator, you'll have a C pop up on the display. And so the next value we want to enter is what's after the C, which is 2. Then you're going to press 2. And then if you hit equals to, you'll get 45. So that's what this whole thing is. This whole thing here is 45 for our example. All right. So that's what the NCX is. All right. So the next part in the equation, it asks for P. If you look at the equation, it asks for P. P is simply the probability of what we're interested in calculating. In other words, defective smartphones. What is the chance of actually having any smartphone having a defect? And if you look at your question, it tells you that from previous experiments and observations, the probability of having a defective phone is 5%. So that's your P. Your P is 5%, 0.05, or you can write 5%, it's up to you. So we have our P, we have our N, we have our X, we have everything to plug into this equation. And I showed you how to work out NCX, which is 45 for our example. Now, if I plug all these values into the calculator, all right, I will get a value of, right, we'll get a value of 0.0746. Or in other words, 7.46%. All right, that's how you work out probabilities for the binomial distribution. So you need to get comfortable with using this equation. All right. So I'll give you a chance to practice a calculation in a second. All right. So don't stress about that. We'll have a chance to actually work that out. Okay. So that is question 2. I'm sorry, that's question 1. Okay, that's question 1. Okay. Now we're going to do question 2, and I'm going to give you an opportunity to actually try this out. Okay. So, and if you're having issues, then this is the time to actually work through it and let me know what difficulties you're having with it. I'm just going to clear the board. All right, I'm going to write the equation again because we're going to be using this equation a lot. All right, so the equation for binomial distribution is P of X, okay, P of X equals X is equal to N Cx P to the X 1 minus P to the N minus X. I'm just going to come back to the chat for a second. Okay. All right. So now we're going to do question 2. Okay, we're going to work out question 2. So the first part is, let's understand what they're trying to ask us and express it mathematically. They want us to figure out what is the probability that at most 2 phones are defective. At most 2 phones. So my question to you is, which one of these mathematical representations represent at most 2? Is it X less than 2, or is it X less than equal to 2? So is it option 1 or is it option 2? All right, put your opinion in the chat. So if we say at most 2, are we talking about X less than 2 or X less than equal to 2? And it makes a big difference on which one you answer. So is it option 1 or is it option 2? So if I say at most 2, is it option 1, option 2? Cool. Getting some input from you. Give it a shot. It's very important that you get this right now. Okay. Let's go back. I think a lot of you say option 2, and you are correct. It is this one. It is this one. All right. So good. Glad that you can identify that. Now there's a big difference when we talk about either one, because if we say X less than 2, then we're only talking about values of X equals to 0, X equals to 1, and that's it. Okay, because if we say less than 2, that means we don't include 2. But if we say X less than equal to 2, then we're talking about X equals to 0, X equals to 1, and we're also talking about X equals to 2. So you can see the difference. There's an extra condition that you have if you had chosen this. So it's very important you know what we are referring to mathematically when we say at most 2. So that's what question 2 is asking us. It's asking us to work out that probability. Work out the probability of X less than equals to 2. Okay, so now there's a bit of a difference to what we did in question 1. Okay, because in question 1, they asked us to work out X equals to 2. So that means for question 1, they wanted us to work out the probability of X equals to exactly 2. But this is not the same thing as what we're being asked now. We have an inequality. And when you have an inequality, that means you got to work out more than just one probability. You have to work out a bunch of them and then add them up. Okay, so I'll explain that now. So in other words, remember what we said. For X less than equal to 2, so this part here, That means you're saying x can take on the value 0, x can take on the value 1, and x can take on the value 2. So in other words, to solve this, we have to work out each of them. So that's equal to probability of x equals to 0 plus the probability of x equals to 1 plus the probability of x equals to 2. You have to get all of them and then add them up. And that's your final answer. Now, we already worked this part out in question 1. So I'll just rewrite that value. This probability of x equals to 2, we did it in question 1. And that value is 0.0746. Oh, oops. 746. All right, let's do the first part, probability of x equals to 0. All right, we're going to use this equation and we're going to work out that value. So you can work through it with me in your calculator. All right, so let's do it. We're going to work out the probability of just this first part here. So now x is 0, and we're going to use this equation. So how we do it, okay. So what we're going to put x equals to 0 into this equation here. And we're also going to use n equals to 10, and we're going to use p equals to 0.05. So how we would enter it in our calculator, remember n is 10, so the first part is 10, so we're going to write 10, shift, and then you're going to press the division button to get your c. The next value is your x, and in our case, our x is 0, okay? 0 here. So it's 0 times p, which is the next value here, which is in our case, it's 0.05. So in your calculator, you're going to probably see something like 10 c 0 times, then you're going to put your p value. You can put it in brackets if you want. It's up to you. All right. I just make it a habit to do that. All right. And then I'm going to raise it to the power x. You look at the equation, you're going to raise it to the power x. And remember, our x in this case is 0 because we work on only this probability. So the exponent button for that, remember, it's your x with a block here. Press that. Okay. It's going to be our x is 0, so you put in 0. Okay, and close the bracket. All right, then times. Then we're going to do this part here. 1 minus p. So it's open bracket, 1 minus, and our p value is 0.05, raised to the power. Take this out. Raised to the power n, which is now this exponent. So we're going to use the exponent button. Okay. Which is this button here for the exponent. N minus, which is our 10 minus 0. And then you're going to hit equals to. Okay, and the value you should get for this part is 0.5987. Okay, so what I want you to do now, I want you to give this a try. I'm going to ask you to work out what is the probability of x equals 1 using this equation here. Okay, you know your n value, that's here. Your n is 10. Your p is 5%, 0.05, and your x is going to be 1. Okay, that's what they're asking. So I want you to use this equation. Okay, this equation here, and substitute these values into it and get the value for me and write it in the chat. Some of you, if your calculator is on stat mode, so just look at the top of your display. If it's on stat, it might be less user-friendly when you're doing these calculations. You may want to bring it back to normal mode. So if you want to do that, just press mode in your calculator. Okay, press mode and choose comp. And then when you use exponents, you'll actually see 2 to the 5, as opposed to seeing 2 with this symbol here at 5. It's up to you. Okay, but you need to be comfortable with using your calculator, because you will have to work out these probabilities using that calculator. Okay, so now give it a shot. I'm going to write the answer. I want you to see if you can work towards this answer. All right, so the probability of x equals to 1, after substituting these values in it, you should get a value of 0.3151. Okay, if you're getting stuck, just let me know. I'll come back to the chat now. All right, let me check the chat. Okay, I'm assuming giving it a try and you're getting that value. Checking the chat here. Okay, anyone getting a different value? You gotta let me know, because I'm just gonna assume that you are and you're comfortable with it. But if not, you gotta tell me. Go to chat. Yes, Daniel, well done. Yeah, those are the three probabilities. 0.0746, 0.3151. Yeah, that's right. Very good. I'm having a network issue. Sorry. Dineo, this X, it's not a subscript. It's in your calculator. So in other words, your calculator above the division button. Just like this. Above the division button in your calculator, there's NCR. So it's actually a value that you just enter when you use this function. So in other words, if I want 10C5, I'm going to write in my calculator 10. Then I'm going to press Shift, then press the division button, and then press 5, and then press equals to. That's how you use the NCR. All right. All right. So for each of them, this is the probability you should have. It's 0.3151. And you got all of them. Remember, in this one, we worked out in question 1, which is 0.0746. So we add all of them up, and that's your final answer. And if you add it up, you get a value of 98.85%. So that's your answer. Okay, that's how you answer that question. So when you have an inequality that you're trying to solve, then that is a cumulative probability. You don't have to worry about the terminology. If you want to ignore that, just ignore it. But when you are adding up probabilities to get your final answer, then you are working out cumulative probabilities. Okay, you're summing it up. So that is the binomial distribution. Let me just go back to the chat and check if there's any questions. Okay, so now you're saying you get the incorrect question. You get an incorrect value. All right, so we'll do this together. Let's say I wanted to get 10C5. No, 10C, yeah. Let's do 10C5. Okay. So what we'll do is, okay, we'll press on in your calculator. Then you're going to press 10 first. Okay. Type 10. Then you're going to press shift. All right. And then you're going to press the division button. Okay. So you press shift, then you're going to press the division button. Sorry, my bad. All right. And then you should see on your calculator display C, and then you're just going to enter the next number, which is 5, because we're doing 10C5. And then hit equals to. And you should get 252. Did you get that?
Hi, Daryl. Yes, now I'm getting it. I think I was just a little bit confused, but I think I came right. Thank you so much.
No problem. All right. So that's the binomial distribution. Now we're going to move on to the Poisson distribution. Okay. Let me just clear this. And I will give you an exercise to practice using your calculator to work out these probabilities. I'll make it available on ARC. Okay, so give me a second. It's gonna go back here. Poisson distribution. Okay, so the Poisson distribution is also a discrete probability distribution. What I mean by that is basically your x values can only take on whole numbers like 0, 1, 2, etc. It can't take on 1.5 or 2.25 decimals, all right? That's for continuous random variables, which the Poisson does not deal with, okay? We are going to deal with discrete random variables in this session. Let me just erase this, and I'll look at the question. I'll kind of give you an idea of how to identify whether to use a Poisson distribution. So remember in the exam, in your second assignment, the question will not tell you to use the Poisson. You got to figure it out. So let's say you're given this question here, or this information, should I say. It says, imagine a local coffee shop in Durban, and based on historical data, the shop receives on average, 5 customers per hour. So the information you're given is you are given time intervals. In other words, let's say an hour from 6 a.m. to 7 a.m. And on average, every hour, so let's say this first part of the morning, they get about 5 customers. So on average, they get about 5 customers. Right? And in the next hour, 7 a.m. to 8 a.m., which is another hour, they get another 5 customers, because that's what the information is telling us. They get roughly every hour, they get 5 customers. So this is a dead giveaway that you should use a Poisson distribution. Why? Because whenever you're given fixed time interval, or time interval, all right, and you are given an average for that interval, right, then that's a Poisson distribution. That's how you should know it's a Poisson distribution. When you're counting something occurring in a fixed time interval, all right? Use that as a guideline of how to identify whether to use a Poisson. So let's answer the first question now. Hold on a second. Okay, so for the Poisson equation, you don't have to worry about memorizing it. I mean, even I don't even memorize it. I use the formula from the formula sheet. the formula for it, and don't be daunted by it. I'll write it out here. Like I said, you don't have to memorize it. This one, give me a second. It's probability x equals to x equals e to the minus, let's use lambda, e to the minus lambda, lambda to the x, all over x factorial. I know, it looks, now you know why I don't memorize it. Okay, your formula sheet may, instead of lambda, it could have a, but just know that it's the same thing. All that lambda and that a means, it's just the average. That's all it is. So if you look at your question, the average that's given to you is 5. So all it's saying is that that lambda or a is just 5. So whenever you see lambda, or if your equation has a instead of lambda, just know that you would replace it with 5 for this example. All right? Okay. And the x is just the value that you're interested in working out. Now, I'll explain each of these terms in the equation, right? The e in your calculator, it's actually something in your calculator. It actually is a number. If you look at your calculator and look at the button ln, which is natural log, look for that button on the far right. Right in the top of your calculator, you'll see a button that says ln. Above that calculator, above that button, you'll see an e with a block like that. So that's the same thing as what you're seeing in the equation. So when you see e to the minus lambda, instead of lambda, let's say 5. Let's say I want to work this out. What I'm going to do is I'm going to press shift on my calculator. Then I'm going to press this ln button. And you'll see that you'll have e with a block here. And you just need to tell it what value you want. So in other words, if I want -5, I'm going to enter -5 here. And hit equals to. And you'll get some small number, 6.7 times 10 to the minus 3. But don't worry so much about this number. I'm just showing you how to use the exponent function. And that's what you're going to have to do in this equation here. Now the denominator, you'll see it says x factorial. X factorial is simply, let's say x was 2. And if I wanted 2 factorial, that is simply 2 times 1. If I wanted 3 factorial, it's just 3 times 2 times 1. You get the idea. 5 factorial, it is 5 times 4 times 3 times 2 times 1. Now don't worry, you don't have to enter all of this. Your calculator does that for you. So for instance, let's say I wanted 2 factorial. Let's say I wanted to work this out. All right, you will look in your calculator, you'll have a button, x to the -1, right? Right in the top of your calculator. Above that, it has x factorial. That's it. That is the same thing we're going to use in this equation. So for instance, if I wanted 2 factorial, let's say I want to work this out, okay? All I need to do is I'm going to type 2, then I'm going to press shift, okay, shift, and then I'm going to press that x to the -1 button here. And you'll see it will give you 2 factorial on the display. And you just hit equals to. And then you'll get the same thing here. All right, so that's how you get the denominator. All right, so that's how we use this equation. But let's start putting in some values into the equation to give you some sort of context. All right, so let me erase some of this. It's going to clear everything out. Okay, so I'll rewrite the equation. Poisson equation is probability x equals x. It's e to the minus lambda. Okay, lambda to the x all over x factorial. That's the equation. So the first question, let's draw your attention to the first question. It asks, what is the probability that exactly 8 customers arrive in the next hour? So just like the binomial distribution, we need to let our x represent what we're interested in. So our x is the number of customers per hour. And so what question 1 wants us to work out is, what is the probability that x equals 8? And so we're going to substitute 8 in our equation where we see x. And our lambda, we're going to replace it with our average given to us in the question, which is 5. Okay, so we're going to enter that in our calculator. All right, so we need to enter e to the minus 5, because that's what our lambda is, times lambda, which is 5, to the x, and our x is 8, divided by 8 factorial. Okay, so we need to enter that in our calculator and then hit equals to. Okay, now if you do that, okay, the value you will get is 0.0653. In other words, 6.53%. That is question 1. Okay, let's check the chat. Okay, all right, cool. Now we're going to move on to question 2, and we're going to use a property called the complement rule. Okay, so let's look at that and I'll talk you through it. Okay, if you're having problems kind of calculating these values using your calculator, we'll do it at the end of this session. All right, but I just want to draw your attention to question 2 now. And so we're going to do question 2 now. Question 2. Okay, the question says, what is the probability that more than 3 customers arrive in the next hour? So what they're asking us here is, what is the probability that x is greater than 3? Now, x being greater than 3 means x can take on the value 4, x can take on the value 5, 6, and it doesn't stop. Now, there's no way I can work out the probability for each of them. That is 4 plus probability of x equals to 5 plus probability of x equals to 6, all the way to infinity. Okay, you'll never finish this and you'll never be able to do it in time. It's just impractical. All right, we need to figure out a way to find a shortcut, but to give us the answer. And that's why we're going to use what we call the complement rule. Okay, so let me just take your attention away from this problem to kind of explain to you what the complement rule is. Okay, so let me just erase this. And I'll explain it. So let's say I told you that the probability that you pass an exam, okay, let's write it out here. The probability that you'll pass the exam is 75%. You have a 75% chance of passing the exam. So my question to you is, what is the probability that you'll fail the exam? What is that probability? If your probability of passing is 75%, what's your probability of failing? Write that in the chat. Check that you're understanding. You need to give me feedback, people. I'll just be talking, and good efforts. I just need to see you try. Okay, make an effort and tell me your thoughts on this. Very good. That is it. Okay, so intuitively, you already know what the complement rule is. It was just a fancy name I may have given it, but you kind of understand it, right? It's just taking 1 minus the probability of something. That's how you got 25%. So in other words, what you did to get that 25% is if you want the probability of failing, it's just 1 minus the probability of passing. That's what you did. That's all you did, all right? It's 1 minus the probability of passing, all right? And that is 1 minus 75%, which is how you got the 25%. That is the complement rule. That is pretty much it. So I'm going to use this here, okay, because it's just no way I can look at all those probabilities and add them up. So my question to you is, if this is the probability of, say, think of this as passing, right? So think of this as the probability of passing, right? So what is the opposite of this? What is the opposite of x greater than 3? Is it, I'll give you two options here. Let me see which one you think is the opposite of the probability of x greater than 3. Is it option 1? Is it the probability of x less than 3? Or is it option 2, the probability of x less than equal to 3? Which of these options is the opposite of this? Is it option 1 or is it option 2? Okay, Tanya, you say option 1. Then you say option 2. No one else wants to give it a shot. Doesn't matter whether you get it wrong. It's not about whether you get it right or wrong. You need to kind of gauge what your understanding is of this, and then we'll take it from there. Okay, so anyone that said option 2, that is correct. That is the opposite. Okay, and here's the reasoning why. Okay, for the probability of passing, which we kind of, I'm making it an analogy with this, right? If the probability of x is greater than 3, that means, remember, x greater than 3, let me just make some space here and I'll write this out. Good, people, I'm glad you're trying and making attempts here, okay? It's good to see that. So let's look at x greater than 3. So what that means is, that is the case where x is 4, 5, 6, all the way to infinity, all right? Now, if you chose option 1, okay, so now if you chose option 1, which is x less than 3, then here, x less than 3 means you can have 0, you can have 1, you can have 2, but you can't have 3, because remember, it's less than 3. Less than means you can't include 3. Now, if you chose this to be the opposite, then you'll see that 3 is not captured here, and neither is 3 captured here. But you have to have 3 captured in one of them. It has to be accounted for somewhere. It can't just disappear. So this can't be the option of being the opposite. Okay? The opposite has to be less than equal to. All right, so that's why the opposite is x less than equal to 3. Because it has to be accounted for somewhere, and it's accounted for here. Okay, make sure you understand that, right? Let me check the chat. Okay, so let me know if you don't understand why it's option 2. Okay, it's very important that you identify that, because if you get that wrong, then you get the final answer wrong. And I don't want to see you do that. So remember what I said, this is the probability of passing. And if I can rewrite it, that is simply just 1 minus the probability of failing. This is the complement rule, which you did a second ago when you did the 75%. So That's what we need to work out. That means I know the probability of failing. I can work this out, which is the opposite. It's 1 minus the opposite of passing, which is this here. As we just said in the poll, you answered that this is the opposite. So it's 1 minus the probability of x less than or equal to 3. So think of this as your failing. So we just rewrote it. Now this I can work out because there's not so many x values I need to work out. For this, I only got to work out probability of x equals to 0, added to the probability of x equals to 1, added to the probability of x equals to 2, and finally, probability of x equals to 3. Once I got all of them, I'll add it all up and that'll give me this value here. All right. And if I do that, which I'm not going to do each one of them, but I'll just show you what the final value for this is because it's following the same principle what we did for question 1. So let me just clear this out. Okay, that is going to be, okay, it's going to be equal, so I'm just going to rewrite this here in the bottom. It's equal to 1 minus probability of x equals to 0. That is 0.067 plus this probability of x equals to 1 is 0.0337 plus the next one, probability of x equals to 2, which is 0.0842 plus the last one, which is probability of x equals to 3, which is 0.144. And if you close the brackets, because everything is added up, and then we just take that sum and we subtract it from 1. And the final answer is 0.735, which is 73.5%. Okay, that's the chance of having more than 3 customers. Now, if you're not sure, okay, how to work this out in your calculator, you're still struggling to work these out, let's do one now, and I'll talk you through it. Okay, because we need to get comfortable using our calculator to work out probabilities using this equation. So let me make some space on the board here. All right, so I'm going to rewrite the equation. Probability of x equals e to the minus lambda times lambda to the x all over x factorial. All right, and now lambda in our question is 5. And let's say x is 1. Right, so we want to work out what is the probability of x equals 1 using this equation here. Okay, so take your calculator out. I'll talk you through it. We're going to go step by step using this equation here. Okay, to make sure everyone's on the same page, put your calculator on comp mode. If you're not sure how to do that, press mode and then choose comp. Okay, mode, and if that's option 1, then you'll select option 1. Okay, so now everyone's in the same mode. All right, so we're going to use this equation. All right, so this is a fraction. Okay, this is a fraction. So let's put it into a fractional mode. All right, so you look at your button that has this here. It has a block, division line, and an empty block here. If you press that, it will go into division mode, and you'll see you'll have a fraction already in the display. And so what we want to enter in the display is, on the top, we're going to capture this part here, the numerator, and the bottom, we're going to capture this here. All right, so the first thing we're going to capture in the numerator is this e to the minus lambda here. So how we do that is you're going to press shift, okay, then you're going to press the the LN button. So shift and then you're going to press the LN button. And you'll see E will pop up on the display. All right. So you'll have E and then it'll be a block here and you need to enter the value. And remember, it's e to the minus lambda. So we're going to put 5 for lambda. So it's going to be minus 5. So you'll enter minus 5 here. Okay, minus 5. Now you need to move the cursor. If you type anything else after this, everything is going to be in the top and the exponent, and we don't want that. We need to move back down to this part here. Okay, so how you move back down is you press your cursor key with the arrow, with up, down, left, bottom. If you press right, if you just move it right, your icon will move down. It moves then to the bottom level. Okay, so if you press right, you'll come down, and then you're going to press multiplication. Right? And so we're saying multiplied by lambda, which is 5. Okay. And now we're going to go back to the exponent, which is x. So you're going to press your exponent button, which is this x with a block. Okay. If you press that, you'll see your icon goes to the top again. Yeah, to capture your x value. And now x value is 1. We're working out the case where x is 1. So you're going to type 1 here. All right. And then once you've done that, now we need to go to the bottom. We need to go here to the denominator. Okay. And how we do that is you just press the cursor key, move down. So tell it I want to go down to the bottom and start typing. And you'll see now it'll blink here. You're in this part here. And remember, in the denominator, we want to write 1 factorial. Okay, because it's x factorial. We're going to replace x with 1, so we're going to type 1. And how do we get the factorial? Okay, remember in your calculator, you've got this button x to the minus 1, and above it, you got the x factorial. So we're just going to press shift, press this button here, and you'll see you have your 1 factorial. And you can press equals to. And that'll give you a value of 0.03 0.0337. Okay, so that's how you work out probabilities using this equation. You need to get comfortable with this. Please practice, okay? It's the only way you're going to get comfortable working out Poisson probabilities with your calculator. In the real world, you'll be using Excel, which makes it a lot easier, but unfortunately, for this course and for the exam, you have to use your calculator. Right, so I showed you how to work it out when x is 1. It's the same principle if x is another value. If x was 0, then all you need to do is change the 1 to 0. It's going to be 0 instead of the 1. All right, that's how you work out the probabilities for any x value. Your lambda will not change, okay, because that's always going to be the average that's given to you. Okay, so that's the binomial and the Poisson distributions. Questions? What's the final answer? That's a good question. You can leave it as 0.0735, but it's good practice to express it as a percent. So Tennille, I would recommend converting it to a percent, but you won't get marked wrong. Hey, that's what you're asking. If you leave it as a decimal, it's perfectly fine. Okay. And provide an interpretation. So just in the end, after you answer this question, just say, write a sentence. It's a short sentence. Just say the probability of more than 3 customers is 73.5% or 0.735. Both will be acceptable. We will not mark you down for that. All right. Any other questions? Everyone good? That is the binomial and the Poisson distribution, which I wanted to cover this evening. Okay, I will make an exercise available for you. So It will have answers to it. It's just a matter of you trying to practice with your calculator and work towards those answers, right? I'll make an announcement for it once I upload it to Arc. Yeah, that's it for me this evening. Any questions? If not, we will call it. And have a good long weekend, everyone. Yeah, have fun.
Thank you. Good night.
Good night.